The, the next talk is brought to us by Bruno Lemaire and Yolanda Yuvara, and they'll be looking at the status and new developments in field portable geochemical techniques and on-site technologies for mineral exploration. Pardon me, I've got a cold coming on. Bruno holds an MSc, a master's degree in industrial and analytical chemistry that he got in 1978 from the Lyon Chemistry School. And he got his PhD in 1982 in geology and geochemistry from the University of Lyon. Since then, he has been a geochemist in a variety of positions with BGRM and with short stints in Saudi Arabia and Antilla. Since 1998, he has been an applied geochemistry expert and international projects manager for BGRM's Environmental and Process Division, with activities for private and public clients in countries all around the world. His main focus is on sampling, field analysis, and instrumentation for mining, environmental, and agricultural issues. He is also a freelance consulting geochemist, so one of those groups that Peter was talking about this morning, and one that's helping us out, in mining and analytical sectors. And so I had Bruno, to you.
Thank you, John. Thank you, Jürgen. I'm very happy to have the honor to talk here about this important topic. That is a part of mobile instrumentation for exploration. So, let me try to get a primer on that. Okay. Mobile instrumentation is having the most difficult way. You have nice places named labs where you can work properly. Why should you take the pain of doing the work on the field in difficult conditions? Second point is, well, we are here for knowing about what happened in the last 10 years. And field analysis definitely developed in the last 10 years. It existed 10 years ago, but it was not routinely used. And now, as Paul Agnew told yesterday, it's one of the most promising routes for exploration. A second issue is, why should we do that? In some cases, we cannot do another way. In some issues, we need that because it gives you flexibility or reactivity for decisions, but also when they can be a most useful complement to laboratory work. It can operate on solids, on water, on gases. It can track inorganic elements. It can track minerals and organics. So, when you cannot do another way, all of you are familiar with water analysis know that part of the work has to be done in the field. People working with soil gas or other volatile organics know you also need to do that on the field, at least part of the work. Flexibility is more important when you're dealing with exploration programs. Most of the time, 30 years ago, we used to wait for laboratory results before knowing what's next, so we had just to plan what's next without results. In that case, it's identification of targets directly on field results where you should sample next. You can select your targets and select the one you will spend more of the time. You can rank the sample you will send to the lab without having going on a blind way. You can work on grid mapping, you can work on further programs, you can do that also on drill holes. And sampling plan can be dynamic in the same way as for environmental geochemistry. So you may end up with fewer lab samples, better selected, and you may focus on lab samples either for making sure of your results or for having the ones with closer to decision level. They are also part of the work which can be on the mining camp, not necessarily on the field. We'll talk about that a little bit later. So reactivity, it's based on the adaptive sampling idea, which came first for environmental purposes. You will sample next where it's more promising or where you find things you didn't expect, and you can sample tighter, you can sample deeper. This is the basis of dynamic sampling plans. You make also real decisions on site with the evening's results. Let's check how far we'll drill tomorrow, how far we'll refine the sampling grid, or how far we'll go up that creek. So what can do with field analytics on solid samples? First is elemental analysis. Geochemistry is quite often about elemental analysis, and there are a large array of techniques which allow us to do elemental analysis on field. First historic one is portable XRF, X-ray fluorescence, which is nowadays the most used field instrument after a pH meter. New technologies came lately. Laser ablation, laser induced spectrometry was LIBS able to overcome the limitation of PXRF, which is light elements. But all the technologies can bring also extra information, like spectral gamma information, which is basically a proxy for a chemical analysis. And I will mention the possibility of using elemental analysis not on the field but on a line. That's mine processing. It's beyond our scope, but many techniques can be shared with solid online analysis. Beyond elements, we have minerals. Minerals usually are addressed with X-ray diffraction. Since the last 10 years, we now have portable diffraction on the site, or in some cases on the field itself, to give a first screening mineralogy, plus spectral methods like infrared methods and micro-Raman methods to identify metals just by spectral measurement. So let's go down to techniques. PXRF later. I know most of you are waiting for that. LIBS was not really on the scene in 2007. So now it's coming on the market. You have LIBS in the vendor area of this conference. You can ask many questions to the people that are here. More information also will come in the workshop on Thursday. So in case you need to have further information, that I think there is still some space for this session. LIBS has a specific session, and in that case you can have an idea of what you can get in light elements. The most critical light element you see is lithium. There will be a talk for lithium, and lithium is something you will never analyze with XRF. You may deduce it using multi-elemental processing, but you won't analyze. Pixel method is just a mention for that. It's not used in exploration right now. It's used by Archometer, but it might be used in the next decade if it provides something else we can need. And spectral gamma has also real importance for the either heavy elements, some critical elements which are companions to thorium and uranium, and also for geology information. Mineralogy, XRD, the diffraction. Actually, the technical progress of instruments in the decade is so important that it needs now to be considered as at least something you may have on an exploration camp. It may need a skilled operator, but it will also help you to define mineral alteration zones, define clay families, and also it allows to screen the samples you will submit to mineralogical laboratory. Once again, the same screening possibility. Infrared, once again, you will have a vendor area which will tell you more, and the workshop which will tell you more. Fast developing right now. several technologies are presented here. Not all of it on this slide. This is based on the possibility of addressing element bonds, not elements themselves. So this can allow you to define your mineralogy, your host alteration zones, and your kind of carbonates, whatever, and as fast as you can do with elemental analysis. So I believe this technique, either in the middle infrared, either in the near infrared, will have a very large development in the next decade. Microray, another new player. It's an old technique, but it's technologically speaking, it went to the field recently. Right now we have a few nice instruments which you can operate on the field. The main advantage of Microray is to offer you the possibility of overcoming limitation on the water contents and organic matter contents in your sample. Infrared doesn't like dark samples. So you can use it for specific minerals for alteration, also secondary minerals, which is helpful for acid drainage prediction. XRF now, the big one. XRF, you know, most of you have seen it. A quick reminder of what you can analyze with XRF on the Mendeleev table. There's not so much change in the last years, but instruments are easier and more sensitive right now than they were in 2007. Time for measurement is around 1 minute, and you can use it to do quick gridding, quick mapping, and quick recognition of geological features, plus detecting spatial structures in commodity elements or in pathfinders. Most of the important the problems with the analytical work done with XRF was due to sample preparation. And most of the problems met by people in exploration trying that as a point-and-shoot device were linked to that. So in sample preparation items for the field are now available, and the better you prepare your sample, the better results you get. So, what's the quality about that? It can be either the perfect fit, like on this screen, if your element has no interference, if your sample is well prepared, and so. You can also have this kind of feature that is okay. You have a nice linearity, but with a bias. It doesn't prevent you to make a decision using such things, but you must keep in mind that the absolute concentration will not be the right one. You have to wait for the lab to get that. You may, on a specific matrix, calibrate your instrument and your field analysis using laboratory results, but don't do that on the blind. Sample representativeness is an issue for portable XRF, which is a very small spot, but it's also a problem for laboratory, and not so many people keep in mind sample representativeness at the time they send the sample to a lab. So your field measurement can check the homogeneity of what you are sending to the lab and how far it's properly representing what you want to sample. You may have also specific biases introduced by laboratory approaches. Let me mention first the problem of, due to digestion. If PXRF is a physical method, so it doesn't take care about digestion, it's total analysis. So if you compare with PXRF results with partial digestion analysis, you may have problems. One example is this, which is from tin and tungsten deposit. If you compare with aquariga measurements, you will have a large bias, which will you not have if you go with total digestion methods, alkali sintering here. Beyond the handhelds, I would say, you have also sight instruments. For first sight instrument you get is the core scanner here. You have a nice item in the vendor area, so you may ask them more questions. They will be also in the workshop. And in that case, you need to go also to the workshop to have information about other kind of during site information. Basically, keep in mind uncertainty has to be considered. If you need a decision level, you need to do that with accurate precision, but in many cases, it will be enough to make your own decision. It will be enough also to decide where to refine your grid, where to spend your time, effectively increase your sample density where you need. You also need to use these results to extend your grid whenever you need it. So it's all over making decision and effective decision on site without waiting. I know some laboratories are doing wonders in providing fast results. Logistics can be also a problem, but in most cases, you have to make decisions before that. A few points are needed to make sure you are on safe ground. First, make an orientation study before you start operating portable instruments or field handheld instruments as your main tool. And for that orientation study, you need laboratory work. The second point is to have a consistent QA/QC system for your instruments. And when you are asking results to lab, there is a QA/QC guy in the lab who does that for you. If you're on the field, you have to do it yourself. You have to do your blanks. You have to do your custom standards. You have to go to replicability test. Everything to do yourself. Do it right. It will pay. Also, always have a laboratory control program behind your results. Don't do something without any control. You may decide before you have the results, but to make sure you need to do that. So, cooperation between field and lab will probably enhance the efficiency of these field methods and also make them much safer. Also, keep in mind, reliability depends on analytical accuracy, but it also depends on the sampling errors. And most of us know that sample uncertainty is at least one order of magnitude larger than laboratory or the uncertainty. You may have larger data sets with field methods, much larger, because it goes faster. It doesn't have specific cost, even if laboratories are cheaper now. So you may have a good quality data set from field methods, but you need to make it safer and sounder with laboratory cross-control. But don't mix field results with lab results. You need two separate maps. They will give the same structure. Yes. So, the strategy before implementing field analytics in an exploration project: first, prepare your laboratory control scheme together as your own QA/QC scheme on your site and make them cooperate. Make safe protocols for the way you measure. It's easy to measure a different way with kind of instruments. So if many people are involved, you need robust protocols. You need standards, but we don't have much standards in field analysis. We have EPA 6200, but not so many. But most important, we need reference materials. The good point is XRF is non-destructive, mineral analysis is non-destructive, so you can afford using certified standards. But in most cases, it's not the most efficient thing. The most efficient is to use project-specific reference material you will build yourself with the correct matrix. Integrate measurement uncertainties. Most of these methods provide their own uncertainties, while in the lab you will get only a bracket of uncertainty, global bracket. And this will help you to integrate your results if you have a plan to run a geometallurgy approach of your site or to do geostatistics. It's much easier with field methods. So your data set will be probably of better quality if you cannot afford enough lab samples. In that case, you have a better data set if you have a large quantity of field measurement. So where you really need field analysis, if you need immediate results for decisions, if you are going to operate in remote locations, or if you simply don't have the budget, but in that case, keep some resources for some lab control. Okay, you will have a lower budget, but don't gamble with your results. Where it brings your real benefits, if you are skilled geoscientists on the area, they will make a better use of these instruments than routine staff. It needs a very close cooperation. You need protocols, you need quality data, and cooperation with a lab and instrument supplier. Most instrument suppliers are extremely helpful. So we expect that if we had some successful application in the last decade, most of us will have them in the next one. Thank you everybody for your attention.